Have you ever wondered how logarithms work in equations and inequalities? Today, we delve into the fascinating world of logarithmic equations and inequalities, breaking them down to their simplest forms. Logarithmic equations are equations where a variable is situated within a logarithmic operation, such as log base b of x equals y, denoted as log bx equals sine y. This notation indicates that b raised to the power of y equals x. Logarithmic inequalities such as log bx, y, depict a relationship where the logarithmic value of a number with a certain base is greater or lesser than another value. Before we dive deeper, it's essential to understand some basic logarithmic formulas. These include the basic logarithm formula, where log base b of x equals y if and only if b raised to the power of y equals x. Logarithmic properties, such as the product rule, quotient rule, and power rule. The change of base formula, which allows us to change the base of a logarithm. Solving logarithmic equations often involves using these properties to simplify the equation and isolate the variable. For logarithmic inequalities, the process might involve transforming the inequality into a simpler form using logarithmic properties, then determining the solution interval considering the domain of the logarithmic function. Logarithmic functions also have unique curves. For instance, the curve of a logarithmic function y equals log base b of x, where b is greater than 1, approaches the y-axis but never touches it, as a vertical asymptote, and increases without limit as x increases. Logarithms have everyday applications. For instance, the Richter scale for earthquakes and the pH scale in chemistry both use logarithmic scales. To illustrate how to work with logarithmic equations and inequalities, we'll solve one simple equation and one complex inequality. For the simple equation, log base 2 of x equals 3, we first use the definition of a logarithm to change the equation into exponential form, resulting in 2 raised to the power of 3 equals x. Simple calculations then give us x equals 8. For the complex inequality, log base 1/2 of x squared minus 5x plus 6 is greater than 0. We first use logarithmic properties to transform the inequality into exponential form. This gives us x squared minus 5x plus 6 is less than 1. We then convert this into a quadratic form and solve for x using the quadratic formula. To sum up, logarithmic equations and inequalities are solved using logarithmic properties and formulas. They have unique curves and are used in everyday applications such as the Richter and pH scales. Remember, practice is key to understanding and mastering logarithmic equations and inequalities. Happy learning!